In my previous video, I set you a few questions on the distance formula. In this video, what I'm going to do is take you through those questions, show you the working and the solutions to them, and give you an opportunity to check how you got on. Quick refresher for you though, these are the questions I set. So the first one, I gave you two sets of points in part A and part B. I wanted you to find the distance between them. The second one was showing that the triangle with vertices, so that's corners, A, B and C, given by these three coordinates, show its isosceles. And the third one was, if the distance between two given points is the square root of 20, what is k, where k is the y part of one of those points. So it's the y coordinate of the point N, as shown over here. So these are the three questions I set. Let's have a crack at them. So the first one is finding the distance between points. Now remember, the distance formula is the key thing you need to know in this. The distance formula was the square root of x1 minus x2 squared plus y1 minus y2 squared. So it was the difference between the y parts, the difference between the x parts. You square them, add them, and then take the square root. And that's exactly what we do for this. Now, you label the points to start with, x1, y1, x2, y2. Doesn't matter which way around you label them. So I could have labelled this as y2 and x2, or I could label this as x1 and y1. It doesn't matter as long as the 1's go together in the 2's. We couldn't label this x1, y2 and x2, y1. That would mess up our maths, but it doesn't matter which way around we label them normally. Then it's a case of substituting them in. So in this case, I'd have x1 minus x2, so that would be 3 take away negative 1 squared plus y1 minus y2 minus 2 take away 4 squared. And then I take the square root of the whole lot once I've added them. So I get the square root, 3 minus minus 1 is 4, so it's 4 squared. Negative 2 minus 4 is negative 6 squared. So it's the square root of 16, 4 squared. 6 is a 36. Remember, squaring a negative always gives you a positive, which then ends up giving me the square root of 52. Now, we could leave this as a third. If we want to simplify it, that could be simplified down to 2 root 13. Question like this, though, they'll want a third answer. Second question here. Here's two more coordinates. I need to find the distance between them. So again, I'm going to label them the other way around this time, just to show it doesn't matter which way around we label them. And then you do the exact same thing, using the exact same distance formula. So in this case, I get distance equals square root of 5 minus 2 squared plus 2 minus 1 squared. So 5 minus 2 is 3, so it's 3 squared, plus 2 minus 1 is 1 squared. So in this case, that gives me square root of 9 plus 1, which is just the square root of 10. That can't be simplified any further than that. We just leave it like that. Now, if it asked for a decimal answer or to a certain number of significant figures, we could put that in a calculator and take it from there. Otherwise, leaving it a third, perfectly acceptable. Second question was showing that an isosceles triangle with these show that a triangle with these vertices is isosceles. So essentially, you've got a triangle like this. So 3 points A, B and C. There's the sides that join up. What you've got to do is prove that two sides, so it could be these two, it could be these two, it could be these two, are the same. Remember, isosceles triangle means two sides are the exact same. So we have to do that. So we're going to have to find the distance of all three sides. So when I find the distance of AB, the distance of BC, and the distance of AC. And two of these should match. Now, even if we find the two in the first go, what we should do is check all three of them, because actually if all three are the same, then we've proven it's actually an equilateral triangle. So distance from A to B, using the two coordinates there, A and B, what I'd end up doing for that one is negative 1 take away 2 squared, plus 4 minus 5 squared. So negative 1 take away 2, so that's negative 3 squared, plus negative 1 squared. Negative 3 squared is 9. Negative 1 squared is 1. 9 plus 1 gives me the square root of 10. Distance of B to C. In this case, it's the square root of 2 minus 1 squared plus 5 minus 2 squared. So that case gives me square root of 1 squared plus 3 squared, which in this case is the square root of 10. So what I've actually shown is AB is equal to BC. So these two sides here are equal to each other. What I want to show now is that this side is not the same. For it to be isosceles, the distance from A to C has to be different from the other two. So for A to C, to calculate the distance of that one, I've got the square root of -1 take away 1 squared plus 4 minus 2 squared. Work both of these out, so -1 take away 1 is -2, so it's -2 squared. 4 minus 2 is 2 squared. So in this case, 2 squared is 4, -2 squared is 4, it's the square root of 8. Which end up simplifying down to 2 root 2. So that there definitely isn't equal to these two, but I've got these two exactly the same as each other, therefore it's isosceles. Alright, and we'd have to write something to show this. So we'd maybe write something that says, since the distance from A to B equals the distance from B to C, the triangle is isosceles. Alright, we have to make sure we evaluate it appropriately and accurately at the end. Now our last question was this one. If the distance between m at 4, -3 and n at 6k is the square root of 20, what is k? So what that means is our distance from mn equals root 20. We have to set this up as an equation and solve it. So our distance from m to n follows the exact same formula. So x1 minus x2, so 4 take away 6 squared, and then y1 minus y2, so plus -3 minus k squared. And I know that that equals the square root of 20. Now because I've got square root of a big bit under here equals square root of a bit under here, I can disregard the square roots and just evaluate what's underneath it. So I could write -3 minus k all squared plus, well 4 minus 6 is -2, and -2 squared is 4. That equals 20. And then it's just a case of solving it. So I'll be able to say, fine, so -3 minus k squared equals 16. And then -3 minus k equals the square root of 16. But remember, square root of 16 can be 4 or -4. We can get two possible solutions when we take the square root of it. We have to take both into account. So from this, what I can do is work that through, and I find that k equals -7 or k equals 1. Now at this point, there's no limitation placed on k. If I'd maybe said k is bigger than 0, it would be this option. If I'd said k was less than 0, it would be this option. There's no limitation placed on it though. So I've got two possible ones there. And that actually makes sense, because if you think about it, there's the point m, and there's my point n. So let's imagine that's at -7. So this would be the one at 6, -7. That distance there could be the square root of 20. However, there's going to be a point that's equally spaced going up this direction to there at 6, 1, where I'm also going to get the same distance. I could create an isosceles triangle almost out of it if you like. So this actually makes sense that there's two possible values. But again, look for any conditions placed in the question, and that will help you narrow it down if it wants that. Hope you got on well with that. See you in class.